I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, December 4th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see sort of a gale, low pressure we'll call it, in the northwestern Gulf of Alaska, generating 20-foot seas aimed off to the east, but really not doing a whole lot. And another gale trying to get organized off the Kuril Islands, but not a whole lot is expected from that. Making a quick look at buoys, we'll start at buoy 46012 Half Moon Bay Buoy for Northern California. We're looking at all the energy present at the buoy, anywhere from up to 30.3 second period. That would be very long period, highly energetic swell, which there is none, the whole way down to 5 second period pure wind chop. We see a little bump here at about 13.7 seconds and then some wind swell mixed in. You integrate all this together and we have primary swell 4.4 feet at 12.8 seconds from about 291 degrees. That comes out to surf size about 5.7 feet on the face, maybe a little bit bigger at top spots with swell enhancing bathymetry, and then a bunch of wind swell about 5 feet at 9.7 seconds. That also is about 5 foot. So two swells, both in about the head high range or so, and both overlapping each other, probably making a pretty warbled mess. Doing the same thing looking down in Southern California, buoy 191, Point Loma, South California, down there, down south in San Diego. We see scattered bits of energy anywhere from 18 seconds down to about 12 seconds, and then wind swell intermixed below that. Pure primary swell, estimated about 2.3 feet at 12.7 seconds, and some other little bits of energy, 1.4 feet at 16.4 seconds. 2.3 foot faces, 3 foot faces, something like that. That'd be at the most exposed breaks. This buoy is less shadowed than some of the others. And then finally hopping over to the north shore of Oahu, Waimea Bay Buoy number 106. Bit of energy there at about 13 seconds and some more at 11 and 9. This is mostly a mixture of wind swell and swell from a gale that was previously on the dateline and had produced some pretty sizable west-angled swell 2 days ago, I believe it was. But that is fading out. Right now, remaining energy, 4.6 feet at 10.4 seconds from 61 degrees and 2.4 feet at 13.6 seconds from about 26 degrees. Maybe some of this is suspect. I think there's still a good amount of energy showing up from about 300 degrees, something like that. Either way, surf 3 to maybe 4.5 feet Hawaiian, so we'll put that at head high, something like that. So let's go take a look and see what's going on in the upper atmosphere. Jetstream level winds. These are winds up about 30,000 feet. They help support the formation of gales. When those gales form, they help direct their track. We're looking for a trough, a dip in the jet, just like what we're seeing there. That helps create sort of an eddy in the upper atmosphere and down at the surface, a counterclockwise rotation to be specific. And that is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface, and they generate seas, and then seas, as they radiate away from the fetch area, eventually impact land, be it Hawaii or the U.S. West Coast, and that's what generates surf. All right, so we have a consolidated jet stream flow with winds about 150, maybe a little bit more, knots, pushing off of North Japan, dipping into a little bit of a trough, but then the jet splits, most energy pushing well off to the north up into the Bering Sea, with a little remnant finger of energy in the southern branch pushing into California, giving us a little bit of the weather that we've been seeing lately. But mainly when you get this split jet stream flow, you can see the return flow coming down here. In this area, you typically just get high pressure, and that doesn't do anything for generating surf. Moving forward, we look into Tuesday, and the split even retrogrades back to the date line or even further, 170 east, something like that. Little cutoff low, though, is forecast developing here west of Hawaii. In fact, you can see it. It's actually not cut off on Monday night, the 5th of December, and then it gets cut off, starts retrograding off to the west. Theoretically, there could be some swell from that, but from the most part, it's not a particularly great situation. Though, look at this. When you get this, when the jet splits back here, it ridges off to the north, and then it comes down and makes that typical backdoor front or backdoor trough situation that has been making the snow that is currently pushing into the Sierras right now, and rain in the San Francisco Bay Area down into Central California. That's a good thing. Looks by Tuesday, more of that pattern to continue, and yet here's another trough on Thursday. Forecast dropping south. It looks like it barely makes it into Northern California, then washes out, and then but continues to just pummel the Pacific Northwest. There was cold temperatures there today, snow on the ground above, 600 or 700 feet, something like that. Oops. And then as we get into Sunday night, Monday, a week from now, yet another, look at this, the big ridge, and then the steep trough off the U.S. West Coast. So we'll see, maybe potential for more precipitation from that. But in terms of swell production, nothing super obvious is in the forecast. Looking down at the surface level pressure, surface level winds, high pressure over the date line, a little bit of low pressure is expected, or as expected off Kamchatka, a little bit of winds of something trying to go on here in the northwestern Gulf, but nothing particularly impressive. Now here's the beginning. Actually, we'll go back just a couple of frames. So we're on Sunday night right now, actually, a little bit of a cutoff low, trying to organize in the upper levels and also creating some winds at 30 to 35 knots, pretty much northwest of Hawaii. And forecast building, we'll pull this away. See, there we go. We got 40 knot, almost 45 knot winds right there, sort of northwest of Hawaii, theoretically on Monday night. And then as we get into Tuesday, 45 knot winds, but none of it aimed at the Hawaiian Islands. So a couple days ago, this was originally forecast developing due north of Hawaii and then retrograding off to the west, and that was supposed to generate maybe some decent solid-sized surf into the Hawaiian Islands. But now with the low, organizing more off to the west and retrograding further from there, the odds for swell start to diminish. So we get into Wednesday, low pressure develops up here in the Gulf of Alaska, backdoor front, maybe gets some traction, 35 knot winds, something like that, with secondary fetch generating another area of 30 knot winds. I mean, that's basically wind swell or just a step right above wind swell for California. And that gets us into the end of the work week. Low pressure theoretically developing off the Kuril Islands as we get into Saturday and Sunday, and another low pressure forecast off the Pacific Northwest and North California as we get into Sunday, pushing right up to the coast. Maybe wind swell as we get later in the weekend, early part of a week from now. And then, yes, winds up here on the, let's call it the northern dateline region, but the Aleutians are right there, probably most of that obscured. Let's go take a look down at the surface, specifically the effect of those winds on the ocean surface. Now we're going to go back in time to Monday, the 28th of November. Low pressure developed on the dateline. We'll blast through this real quick because the bulk of the swell has already passed Hawaii and even the U.S. West Coast, and is not of any particular concern, but just sort of a review of what's been happening. Then on Wednesday night, Thursday, the 1st of December, low pressure developed off of the Pacific Northwest, falling south. That's what produced swell that hit into California on Friday. And then a secondary system developed on Saturday, pushing down the coast. And here we are currently, it's fading out. And this is what has produced some swell, at least north of Point Conception today. Nothing huge, but there were waves, a couple feet overhead at top spots. But south winds, pretty ragged conditions, at least in the San Francisco Bay Area. Looking forward, we're not expecting to see a whole lot. Little spurious bits of seas in the 24-foot range up here in the northwestern Pacific. But again, the cutoff low right about there. Where's the peak? We'll put it right there. We'll pull this away. 26-foot seas aimed south, maybe wrapping around the low a little bit at the Hawaiian Islands, Kauai, and Oahu. This would be on Monday night, so maybe swell into, let's see, you can actually see the front of it there. So you could say Tuesday, Wednesday sort of thing. Size a bit undetermined yet. The thing hasn't even formed, so you don't want to forecast swell heights when the fetch is not even blowing on the ocean surface yet. But theoretically, some surf, indeed. All right, as we get into Thursday, December 8th, the next opportunity, at least for the U.S. West Coast, was at 25.1 foot seas in the northern Gulf of Alaska, falling southeast, maybe some swell that would arrive into Friday and maybe Saturday. You can see secondary fetch and 18-foot seas, something like that. Relative to Hawaii, not a whole lot going on. We're a week out now. Then spurious bits of energy, but no clear organized systems. The jet stream's still kind of weak. The La Nina pattern just kind of really not stealing energy. Inactive phase of the MJO, all that sort of stuff, just not a good jet stream pattern. Anyways, we get into Monday, maybe more low pressure off of California, making for more, we'll call it northwesterly wind swell. Wind forecast for Hawaii and the U.S. West Coast. Trades on Sunday for the Hawaiian Islands, southwest winds at 10-15 knots for most of North California down into Central California. Low pressure, still very weak low pressure, still lingering off Cape Mendocino as we get into Monday. Still producing we'll call it a weak onshore flow, just enough to sort of junk things up. The low pressure. Let's go back and take a look at this. The low pressure system. So Hawaii here's your fetch. You can see it's like northeast winds, almost due north winds right here. This is on Monday morning, and then by the time it gets going, 45 knot northeast winds well west of the Hawaiian Islands, maybe a little bit of fetch down here pushing at the Hawaiian Islands, maybe some swell to result. And what is that? Southeast winds, that would be on Tuesday. As we get into Wednesday, light northwest flow for the U.S. West Coast. Pretty strong trades, 20 knots for the Hawaiian Islands. As we get into Thursday, here comes another front trying to develop south winds north of the Golden Gate. Strong trades, 20 knots for the Hawaiian Islands. The front pushing down to, we'll say, somewhere around maybe Santa Cruz on Thursday. By Friday, a light northwest wind flow for North and Central California. Strong trades for the Hawaiian Islands. Saturday, more of this kind of onshore southwesterly flow, we'll say from just north of Santa Cruz, Half Moon Bay, points north of there. Trades for the Hawaiian Islands. And Sunday, a lighter wind regime, but we know low pressure theoretically is to be building off the coast. This actually looks pretty solid from this view. We'll see what happens, though. The models have not been very good more than a couple days out, it seems like. Precipitation for this California, looks like the dividing line right now, somewhere around Santa Cruz. Light rain. I mean, up here in San Francisco, it's not raining. It hadn't rained all day. The model's showing it. But there has been light, steady, wet, very wet snow in the Siera. I think since Friday, somewhere in the area of maybe 30 inches of snow. But it's not light snow. Temperatures down at the base hardly got to freezing through the whole, certainly the latter half of the event. So whatever good snow did fall will probably have a blanket of wetter, probably near frozen stuff on top of it. Up high, though, above about 8,000 feet, conditions were much more favorable for snow production. As we get into Monday, another front, more snow for the Siera, rain down to about Santa Cruz, something like that. Tuesday, maybe scattered showers down into even Southern California. Wednesday, things dry up. We know another front's coming. It arrives Thursday night, pushing down the coast to, we'll say Big Sur, with some light snow for the Siera. Another one behind that. I mean, this is actually a pretty good pattern, with rain Saturday working its way again down to about Santa Cruz. Light snow for the Siera. That fades out, and then theoretically a far bigger, more vigorous storm off the coast, but that's more than a week out. Don't believe any of it yet. Snow forecast dashboard for Palisades, Tahoe. Total accumulation somewhere around 28 inches, something like that. For Kirkwood, wow, big difference here. Was that 14, 15 inches? Just a little bit further south, and that really highlights that dividing line. Let's see what Mammoth is forecast to get. And then really next to nothing for Mammoth. Very interesting. So really the line is North Lake Tahoe and north of there. Looking at the snow levels for Palisades, Tahoe, well, this is the base of Squaw, 6,200 feet. The reds would be liquid precipitation or above 32 degrees. The grays is really sleet, so this is like 36 degrees. The transition from the gray to white is the 32 degree line. Either way, freezing level below the base of Squaw the whole way through until December 11th, peaking up a little bit and then sort of tickling just at the base or above the base beyond that. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation are two major oscillations that affect weather and swell production long term over the Pacific Basin. We start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation, this periodic weather oscillation that goes around the planet in two phases, an active phase and an inactive phase. Active phase on one side of the planet, inactive phase on the other. They rotate west to east around the planet on the equator, okay? When the active phase is effectively a low-pressure system, when it starts moving over the Pacific, it imparts energy to the jet stream, feeds it, makes it strong, which in turn then supports stronger storm development. It also can, because it's low pressure, it dampens trade winds, and when that active phase pushes across the equatorial Pacific, dampening trade winds, it enables warm water that's typically pulled up in the West Pacific to start sloshing east. That travels under the equator in the form of a Kelvin wave, a ball of warm water, that eventually impacts the Galapagos Islands and Ecuador, erupts to the surface, and creates a warm water slick. If you get successive active phases of the MJO and successive Kelvin waves, that can help usher in El Nino. So and of course everyone knows that El Nino is great for storm and swell production in the Pacific. If anything, it pushes it over the top and makes it maybe a bit unrideable at times. All right, so we're looking for signs of the active phase of the MJO. And the inactive phase does basically exact opposite. It supports high pressure. It increases trades. It takes warm water that we want to be in the East Pacific and pushes it all off to the west. And if you get successive inactive phases of the MJO over the Pacific, then that can help usher in La Nina, and that's exactly where we've been for 2+ years now. All right, so we're looking at data from the TAA buoy array, a series of buoys strung across the equator used for monitoring El Nino, but we can use the wind sensors on those to look for the presence of the active phase of the MJO. We're just looking at the arrows here. This is the East Pacific here, West Pacific here, the equator here, dateline right there, New Guinea right there. Kelvin wave generation area, we call it, the far West Pacific, and only from 5 north to 5 south, from the far West Pacific, 135 east to about 170 west, so a box right in there. That's what you want. In these arrows, we can see this is 5-day average trade winds, or winds, pretty much out of the east. The longer the arrow, the stronger the wind. So pretty strong out of the east and the East Pacific, pretty strong over the Central Pacific, and strong over the Kelvin wave generation area. But it is not the average winds. It is the anomaly, the difference from normal for this time of year. So you can see these little baby arrows out of the east. That's saying that the trades in this area are just a little bit stronger than normal because they blow typically pretty hard this time of year. Over the Central Pacific, same thing. We'll say modestly stronger than normal. Over the Kelvin wave generation area, moderately stronger than normal. So rather than seeing suppressed trades, we're seeing enhanced trades. So this suggests the inactive phase of the MJO. Let's go look at the forecast for the next 2 weeks. Actually, for the next week. Okay, so this is the GFS model. This is just showing 850 millibar zonal wind anomalies. In other words, are the winds stronger out of the east than normal or stronger out of the west? If they're stronger out of the east, that means the inactive phase of the MJO, like right here, the blues and purples. The reds and oranges are stronger out of the west, the active phase of the MJO. All right, so the area we're interested, now this is the whole plan on one chart. The date line runs right up the middle right there. Kelvin wave generation area starts about 135 east. That's the far west Pacific. You can go right up the chart. And it ends at about 170 west, so right about there. So this area, forecast-wise, is what we're interested in. So this looks back in November, inactive phase of the MJO. A weak active phase with westerly anomalies tried to push across the Pacific somewhere at the end of November. And now it looks like inactive phase again. And this is the typical pattern, the La Nina pattern. East anomalies locked over the dateline, west anomalies over the maritime continent. We're looking for signs of these westerly anomalies to be making more progress into the West Pacific. So then we go out, let's look out 2 weeks. Outgoing long wave radiation, fancy words for cloud cover. The blues mean more clouds. They're negative numbers. That means less sunlight reflectivity off the ocean surface. Okay, and let's get ourselves oriented here. South America, that'd be Chile and Peru. Central America, Hawaii, New Guinea. Dateline 180 west right there. The equator, EQ right there. So today, basically no MJO pattern, no enhanced anomalies or suppressed anomalies. We go out 5 days, no change. We go out 10 days, no change. And this is the statistical model. It says 2 weeks out from now, 15 days. Maybe the inactive phase of the MJO moving into the Kelvin wave generation area. The dynamic model saying pretty much the same thing, only the inactive phase very weak, showing up 5 days from now and traversing across the Pacific over the next week beyond that. The GFS model going out 2 weeks, 925 millibar zonal wind anomalies. So this is up maybe only 1,000 feet. Let's get ourselves oriented right there. That's the Galapagos. You can see just the very hint of Ecuador right there. Central America, Mexico, Hawaii right there. New Guinea right there. The equator right there. Kelvin wave generation area cuts off at 170 west. The area we're really interested in is right in here. The purples are easterly anomalies. The reds are westerly anomalies. So we have some westerly anomalies in the far east Pacific, which is good, but where we really want them to impart energy to the jet stream is right in here. And we do see westerly anomalies just north of New Guinea here. All right, and we'll put this into motion. We'll just see how this plays out. We see the continuation of little westerly anomalies while easterly anomalies fade as we get into December 8th. But then the easterly anomalies come back. They just are persistent. They won't let go. And we see westerly anomalies trying to creep in from the south and the north. This is on December 14th. But they don't really, there they go. They almost cover a portion of the Kelvin wave generation area for a couple of days. And then the easterly anomalies again show up. They just will not die. The upper level model. This is showing propensity for precipitation. The greens, areas favorable for precipitation. The oranges, dry air, not favorable. One can assume this dry air would be the inactive phase of the MJO. The green is the active phase. Let's get ourselves oriented. Oh, this goes out 40 days, 5 days each panel. The equator right there. South America, Central America, New Guinea, the Kelvin wave generation area right around here. This is what we're looking for. We want to see greens over this area because that means energy would be imparted to the jet stream theoretically. So we see some of that starting about mid-December, going through, about the end of December. That would be the active phase of the MJO making its way across the Pacific. Then after that, a little bit of the inactive phase, but in general, and this has been pretty much the pattern for a while now, a very weak MJO pattern, nothing strong. We're really looking to see some strong active phases of the MJO, and we haven't been seeing it. 850 millibar zonal wind anomalies going out 1 month from the CFS model, all right? And this is, again, the whole plan on one chart. Blues, easterly anomalies, think of that as inactive phase of the MJO. The reds, westerly anomalies, think of that as the active phase of the MJO. The date line right here, Kelvin wave generation area starts right here and goes to about here. Now, according to this model, and this is from a day ago, westerly anomalies are, in fact, over the West Pacific. And suppose I'm looking over the microphone here. That's kind of why my head's bouncing around here. But you see westerly anomalies forecast filling about 2/3 of the Kelvin wave generation area into mid-December, something like that. And then they fade, but neutral winds continue, and you can see this dotted contour right here. That's the inactive phase of the MJO, theoretically traversing the Kelvin wave generation area the whole month of December. That's different from what we saw from the upper level model. The point sort of being the MJO pattern is exceedingly weak. You can see it here. None of these, no MJO has really even made it halfway across the Kelvin wave generation area for, since September, and it's certainly been longer than that. That still appears to be the case. But the good news is westerly anomalies, or at least neutral anomalies, are trying to make more of a push into the West Pacific. In fact, you can see it on the jet stream. Remember when we were looking at the jet stream chart? It pushed off of Japan, made it right to the date line, and then it would split. That is being driven by these westerly winds. The more of this area that can be filled with westerly winds, the further the jet stream will make it across the Pacific. Now, the plus side is, well, if the westerly anomalies only make it halfway to the date line, well, then at least if you get the split jet stream, the jet goes north, we get the backdoor fronts coming into California, and we get rain, and we get some precipitation. So that's certainly a plus. The downside to that is you get a big ridge over the bulk of the North Pacific, and then it becomes very difficult to get meaningful storm development and therefore swell development. This pattern suggests a continuation of that. This is actually better than where we've been, where it used to be nothing but solid easterly anomalies filling the whole Kelvin wave generation area. Somewhere about even October 15th, right here somewhere, is when we started to get westerly anomalies making inroads into the Kelvin wave generation area. And it looks like that pattern is continuing. So the models have not misled us as to the future. But the real question is, how strong are the westerly anomalies going to be, and how big of an impact is it going to have on the jet stream in terms of surf production? And that is still very much a question. And then finally, the CFS model going out 3 months. This is past performance down here. This is the forecast up here. What we have been talking about, the blues or easterly anomalies, inactive phase of the MJO or the La Nina signal. You can see looking forward, well, this was supposed to completely disappear. This big ball of blue here was not on the forecast a month ago. The good news is, well, it's on the date line or east of the date line. And the other good news is westerly anomalies basically filling the Kelvin wave generation area and only becoming more entrenched and filling the bulk of the Pacific as we get towards the end of January. So not such a bad pattern. Let's overlay the MJO here. All right, so right now, dotted contour, inactive phase of the MJO, but very, very weak. And again, Kelvin wave generation area starts about 135 east, so right up here. and to 170 west. So this is the area right in here that we're interested in. Westerly anomalies today in control. Easterly anomalies pretty much from the date line and points east of there. And forecast holding as we get deeper into December. Active phase theoretically pushes across the entire Pacific. That's good news. With enhanced westerly anomalies filling the entire Kelvin wave generation area, and if not traversing the entire Pacific. Beyond that, as we get into later in January, the inactive phase of the MJO sets up, but with westerly anomalies still in control. So what the model said 2 months ago or more still seems to be the case. It's not quite as impressive as what we were looking at and sort of hyping up a little bit 2 months ago, but still the change is ongoing. Let's overlay the low pass filter here. So this is the high pressure, low pressure bias. Dotted contour here, high pressure, the La Nina signature. Okay, still present, but come about Christmas time, the second contour line is to dissipate. And the first contour line, notice from here forward, it starts slowly inching off to the east. And as we get into about mid to late January, it completely pushes east of even the Kelvin wave generation area. That's good news. The low pressure bias, this solid contour, still holding right with what was predicted even months ago, that it's slowly from here forward working its way. You know, someone said it's like watching paint dry. Well, it really is. But little bit at a time, this change is setting up with the low pressure bias working its way deeper and deeper into the Kelvin wave generation area. And by March, it's basically low pressure bias is across the date line, filling the entire Kelvin wave generation area. So the $1 million question will this movement, these westerly anomalies, all this, will this impact the jet stream and help the jet stream to be more consolidated, to push further east from the date line, deeper into, we'll call it the East Pacific, and will that actually help fuel storm development and enhance precipitation into the U.S. West Coast? Big question. We don't know, but we're keeping our fingers crossed. All right, let's keep going. All right, so what is the ocean doing? And not at the surface, we're talking down in the ocean. We're looking at data from the TAA buoy array, again, those series of buoys used for monitoring El Nino. We're looking down 100, 200, 300 meters. That's like 900 feet, almost 1,000 feet down. It's really the upper 300 meters of the ocean that we're most interested in. These little lines right here, these are the anchor lines on the buoys. The X's are sensors on the anchor line. The sensors collect temperature data down in the ocean and then relay it up to a central processing facility. You can see there's big gaps between each array of buoys. Use a model to fill in the gaps, and then you get a profile of what the subsurface temperatures are doing. Why do we care? We're looking for Kelvin waves. We're looking for warm water moving off to the east. All right, the 29 degree isotherm, 29 degrees centigrade isn't even present. 28 degree isotherm is at about 175 east. That's where it was last week when we did our video. The 26 degree isotherm, it's actually, I think it was at 155 west last week. It's easing east a little bit. Not real any clearer sign of a Kelvin wave, but a little bit of eastward movement will take. The 24 degree isotherm, well, it was back at 135 or something like that. Now it's at 125. So it's trying to push off to the east a little bit, but it's not actual temperatures. It's, again, the anomaly, differences from normal for this time of the year. And we clearly see warm water. This is pretty much what a Kelvin wave looks like, but it's even more than that because it's not a single ball. It's like just like a river of warm water. This line, so this is 4 degrees centigrade above normal temperatures. Right now, the dividing line between that and cold water, the La Nina, the last of the La Nina cool pool, 3 degrees below normal. Well, the dividing line, let's see, we'll go right up here. That's 130 west, so right at about, we'll say 130 west. I mean, this was locked solid at 150 back here a month ago. So clearly, warm water is pushing off to the west. What's driving it? Well, we talked about those west anomalies slowly, tenuously building across the West Pacific. That's what's driving it, for certainly. You have to have westward or at least reduction in trades to get this water to move. So this is a good sign. Looking at another model, this is the model that's, I'll call it more conservative. It actually shows the temperatures being much warmer in the west, but much colder in the east. It too is showing this finger of warm water making it to right about 130 west, something like that. And this is even a week ago, so it's probably even further east than that. Again, warm water, giant Kelvin wave, trying to ease off to the east, and we haven't even really had a quote-unquote active phase of the MJO. What we're getting is this just slight, slow weakening of trade winds over the West Pacific, and that's enough to take all this warm water and start to put it in motion. Sea level anomalies. So these are not temperatures, this is the height of the ocean, and there's good news here as well. All right, so this is data, satellite-derived data. You beam a radar off the ocean surface, and you can measure tiny fluctuations in the sphere of the ocean. You take the wind waves out, the swell, even the tides, take that all into consideration. Is the sphere of the ocean higher than lower than normal? Why do you care? Well, cold water at depth contracts. It'll create a divot on the ocean surface. Warm water down at depth will expand and create a bump on the ocean surface. So we have these big, high anomalies, positive anomalies, 20, 25, 30, 15, 20, 25, positive anomalies suggesting piles of warm water. Oh yeah, and this is the equator here, date line there, New Guinea right there, Kelvin wave generation area right in here. Lots of warm water at depth here. But notice you're getting 1, 2, 3 little positive bumps, and the dividing line between the negative anomalies, which one can assume is cool water at depth, now the dividing line is right about here, right about 140, maybe 142 west. This also suggesting that warm water, almost like a bulldozer of warm water right here, is starting to push off to the east. And what was a much larger cool pool right here is shrinking compared to last week and getting pushed off to the east. In fact, we can see that better on the next image. This picture really tells the story well. This is upper ocean heat anomalies over time, going back a year. West Pacific here, East Pacific here. The reds and oranges, much warmer temperatures. The blues, much colder temperatures. This is a Kelvin wave last January, made it the whole way across the Pacific. La Nina upwelling. Another Kelvin wave somewhere in the May, June, July timeframe, didn't even make it to the Galapagos. And then we had this raging cool upwelling event that started in July, and it held solid till about the time we got to November. And it was actually October 15th is when the first little bit of westerly anomalies started building over the far West Pacific. And you can see this steady movement since then as the westerly anomalies continue to make inroads into the West Pacific. Temperatures, the cold, the dividing line between the cold and the warm is getting steadily pushed off to the east. And notice this, the big pocket of what was the coldest of cold waters last week, we thought, wow, it's still locked in place. It's gone now, and the line clearly moving off to the east. This suggests that westerly anomalies, no matter how faint and weak they are in the West Pacific, are having a definite impact on massive amounts of water down in the ocean surface. There is a tremendous, now I'm not trying to overstate this is not like some El Nino thing happening, but there's this subtle, steady trend going on in the Pacific right now, and we think it is not going to reverse if you believe the models, and that a wholesale change in the heat balance in the equatorial Pacific is in flight as we talk. Sea surface temperature anomalies, that's the next part. Now, we saw warm water making its way off to the east down at depth, but at the surface, the blues, colder than normal temperatures, the reds and oranges, warmer than normal temperatures. All that really matters is from about 5 degrees north to 5 degrees south. So this area right in here. You can see the blues clearly colder than normal, the La Nina signature. Now, let's get Chile here, Peru, Central America, Mexico, Hawaii. This is and the Galapagos right there. Colder temperatures, but you know what? They're not as cold as they were a week ago, 2 weeks ago, and especially down here in this area from about 5 south down to 20 south. Steadily warming in this area. And also look at this, a little bit of warming building up off of Chile and even off of Ecuador. Not saying that this is any sort of a Kelvin wave thing, but remember in the westerly anomaly charts that we were looking at, there were light westerly anomalies building over this portion of the Pacific. I think the trades are getting knocked down and have been getting knocked down here. And what all that does is it inhibits upwelling, allows the sun to start cooking the ocean surface a little bit better, and that starts warming things. And then the more warming you get, the more it starts to allow evaporation to occur, and that starts cutting into the La Nina-induced high-pressure systems, both north and south of the equator, and that helps feed the change that we think is going on. Sea surface temperature trend the past 7 days, so not looking particularly impressive right now. In fact, it's showing little pockets of cooling here. Oh yeah, let's see, this is Chile, Peru, Central America, Hawaii, the equator right here. The area we're interested, the Nino 1.2 region area, is right in here, right off of Ecuador. The official El Nino monitoring region is from 120 west, 5 degrees north and south of the equator, out to 170 west, so right here. But this is just a 7-day trend. I was pretty excited earlier this week because this whole area was really baking warm, and we still have a warming trend off of Chile and Peru, and in little pockets out here, but temperatures moderating some now, not quite as impressive as it was. And then the backed off trend, or backed off temperature trend. You can see clearly colder than normal water here right on the equator. And yes, it's colder down to 20 degrees south, but the intensity of the cooling down is significantly eroded even compared to 2 weeks ago. In fact, let's go look at some historical. Somebody actually asked, well, can you go and just sort of give us how has things changed over the past year or a couple of months, something like that. So we grabbed a couple of images here. So we're going to go back a year ago, the 1st of December, 2021, still in La Nina. Look at this picture. It's really no different than what we're seeing right today. But also notice the intensity of the cooling down here and all up along Chile and Peru, much colder than it was. And certainly the temperatures right here, way colder than what we are seeing today. Then we go to August of this year, and there was a Kelvin wave erupting, the summer Kelvin wave. You can see warm water starting to build around the Galapagos and out off east of there, but still cold water here, cold water, this whole area basically cold other than this little area here. And then October of 2022, again, cold indeed, clear La Nina signature. And then today, you see cold water warming here, warming off of Peru, off of Chile, warming off of Peru just slightly. And this could all come or go, but with westerly anomalies building over here, high pressure here, weakening, with the thought is this steady, slow warming trend is going to continue. And then for fun, our last El Nino. Now notice the big difference here. There's no blues here anywhere. If anything, it's much warmer than normal temperatures. This is the classic El Nino signature. This was December 16th, 2015. That's 7 years ago. That's the last time we had a significant El Nino. The point being, we are definitely due. You can see warming the whole way from Ecuador, the Galapagos, the whole way out to the date line, 5 degrees or 10 degrees north and south of the equator. The 20-degree line is down here. So this is what we want to see, and here's where we are today. So a big contrast, cold versus warm. We're hoping to get warming in this area, because when you get warming, You get evaporation that imparts energy to the jet stream. You get Kelvin waves. All sorts of things happen. We're in the exact opposite place of where we want to be, though we are slowly, steadily moving in the right direction, finally, after 2 years. Sea surface temperature anomaly, the trend, temperatures sliding up slightly just the past 10 days, something like that. We were just totally locked down at minus like 2 degrees. Today, minus 941 thousandths of a degree. You got to be at half a degree to be at the low end of the neutral, neither La Nina or El Nino. We're not there yet, but at least we're moving in the right direction. The Nino 3.4 region, the official El Nino monitored region today, again, 968 thousandths of a degree below normal. We got to be up at half a degree. We're not there, and we're not even trending in that right direction yet. Though you can see we have been warming, but we need a lot more of that. So what's going on in the atmosphere? What does the atmosphere think is going on? All right, we look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, which is in the Indian Ocean, and Tahiti, which is in the central South Pacific, we'll say. When pressure is lower in Tahiti in the Pacific, and that's what we want, the index is negative. Well, it's not negative, it's positive. Today at 15.31. Looking when pressure is positive like that, that suggests pressure is higher over Tahiti. That's a La Nina signal. Going back, now we had a pretty good run here. In fact, all of November, we were more or less below 10. The index was below 10. But then just recently, we've started going back in an upward direction, probably because of, I'll say, some weak version of the inactive phase of the MJO setting up. The 30-day average SOI at 6.14. It was down at 4.18 about, what was that, maybe 8 days ago, something like that. Prior to that, it was up at 15.78 and even higher than that. So we were moving in the right direction, but now, again, this inactive phase, or what, there's just this sort of a weak high pressure regime is setting up again. The 90-day average, plus 14.18, still clearly in La Nina territory, but basically unchanged for the past month. Let's look at this data graphed out. Here we are, 30-day moving SOI on a graph. Upward spikes are the inactive phase of the MJO. Downward spikes are the active phase of the MJO. We've been on a good, long downward run. Neutral is right here at 0. So up here is all La Nina territory. Down here is all El Nino territory. We were heading down. We knew it would start creeping up at some point, so it's doing that. But again, with the models suggesting westerly anomalies building over the West Pacific, with the low pressure bias moving more into the West Pacific, at some point this is going to continue to start falling back downward. We don't think that we are going to get in one of these big upward spikes at this point. If anything, this index should start to fall, signaling the demise of La Nina. And then finally, the forecast for temperatures in the official El Nino monitoring region, the Nino 3.4 region from the CFS version 2 model. And this is pretty consistent with what all the other models are saying. So somewhere come about, this would be mid-December, temperatures are going to bottom out. We think we're very close to there. It's what, December 4th, so we've got 10 days, something like that. And then from then on, temperatures start rising upward. This is the raw data. So pushing 3/4 of a degree or 0.7 of a degree by mid-January. And officially, there's that magic half degree below normal line. That's the transition from La Nina into ENSO neutral. That should happen maybe the last week of January, the first week of February. And according to this model, well, look where this line goes. It's up to plus 1 degree. So neutral on the upper end is at a half a degree. This says El Nino as we get into the summer of this year. Now, that's the raw data. The PDF corrected data also showing very much the same thing, but even a little bit better, suggesting temperatures at about 0.65 of a degree as we get into mid-January. And by the end of January, we're at ENSO neutral, trending upward from there. 3/4 of a degree above normal in El Nino territory as we get into July. So, again, this is all about this transition that we think is going to happen somewhere in the next week or two. So we're very close. Westerly anomalies continuing to slowly creep across the Kelvin wave generation area. Temperatures slowly subsurface in the ocean. Looks like a massive Kelvin wave trying to push across the Pacific, but it's not really a Kelvin wave. It's more just like pent-up warm water that's sitting there, that's been held in place in the West Pacific for 2+ years now, slowly starting to slosh back to the east as trade winds give up. The Southern Oscillation Index also suggesting that pressure is falling across the Pacific. All this is consistent with what the models have been saying for months now, that La Nina is fading. According to the models, by somewhere in January, maybe the end of January, La Nina is supposed to be gone. We're supposed to be in ENSO neutral. The thought is, when that happens, the jet stream will get more energy. The storm production will pick up. Right now, our surf forecast, not looking very good. There's really no significant or even moderate storms forecast for the next week. We think that'll be a bit short-lived, though. As we get deeper into December, things should wake up. We have our upsides, we have our downsides. We've been through a pretty good run. Hawaii's gotten a couple of fairly decent swells. The U.S. West Coast, not so lucky. Just the dividing line is where the westerly anomalies end, and right now they're not even quite making it to the date line. They need to make it further across the Pacific, but all data suggests that's exactly what's going to happen, and that as we get deeper into December and January, somewhere around the end of January or February, things should wake up and a dramatic change should set up, if you believe the models. But so far, they've done a really good job. Everything that they've been predicting is happening in reality. It's not dramatic. It's like watching paint drying, but every week it seems like we're making little progress in the right direction. All right, that's it for this week. Hope you enjoyed the video. If you did, give us a thumbs up. If you have any questions or concern, write it up in the comments section. We'll be happy to answer them. I know we cover a lot of detailed information here, and almost an hour's worth of it. I know it can kind of make your eyes roll back in your head, but to me, I find this stuff interesting, and I like to share it with you. All right, that's it for this week. We'll do it again next week, same time, same channel. See you then. Take care.